All right, this is fantastic. I have got my Aspire project now. I can launch my Azure Functions locally on my machine, but now I've also got these functions that need to react to messages on Azure Service Bus. So I've written the function code, I've set up my Service Bus trigger, I've got the code that's handling the message when it's sent to the Service Bus queue. Now I need to test this locally as well. Previously, when I ran the Azure Functions integration with Aspire, it just started up the API, it added an API endpoint, and I could call that API endpoint. But how do I call an Azure function that's hooked up to Azure Service Bus? That sounds like a problem. Hi, I'm James Eastham, and in this video you're going to learn how you can leverage .NET Aspire to dramatically improve the local development experience for building Azure functions that react to asynchronous event sources, things like Azure Service Bus. Now I know what you're thinking. In the last video, we looked at running Azure functions locally where you're interacting with it over HTTP. You're making API calls, you're running your API on Azure functions. And in that video, I talked about emulating the cloud locally and the challenges with trying to emulate the cloud locally. Which begs the question, how far do you actually start to go with trying to run things locally on your machine? Do you try to find a way to emulate all possible event sources that Azure Functions has, getting to the point where you've basically rebuilt Azure on your machine? If you hadn't already thought it, the answer to that question is no, really. Helpfully, Azure themselves provide a few in-house built emulators that give you some pretty useful features when it comes to building Azure functions that react to different event sources. And the first of those is the Azure Service Bus emulator. Now, Azure does have a few different services for building message-driven systems, and there's a really awesome video from NDC Oslo earlier this year from Daniel Marbach. I'll put a link to that in the description below that covers Azure Service Bus, Azure Event Grid, and Azure Event Hubs, and when you would use each one. For the video today, we're going to focus on Azure Service Bus for building message-driven systems with Azure Functions. And Azure provide the Azure Service Bus emulator. Now, of course, there's always challenges with trying to emulate cloud services on your local machine, but when it comes to just debugging Azure functions locally that are sourced by Service Bus, this is a really good tool to use. So you've got the Azure Service Bus emulator, and you've also, as we saw in the last video, got the Azure Functions integration for .NET Aspire. Now, at the time of me recording this is of course in preview. By the time this video comes out, this may well be GA. Some of the stuff you see in here may change slightly, at least from a structural perspective in terms of how you call the different functions. But when you look at the Azure Functions integration for Aspire, you'll notice that they list the supported triggers that are available when you're running Azure Functions locally inside Aspire. You've got the HTTP trigger, which we used in the last video, and then you've also got this bunch of other triggers for various different services. You've got the Service Bus trigger, Blob trigger, you've got the timer trigger, which is really cool for testing things like background workers that are running on a schedule. So you've got this suite of actually a pretty exhaustive list of event sources that you probably need to use when you're building with Azure Functions locally on your machine. How would you actually go about doing that? So let's first have a look at the Aspire project for Azure. And if we just have a quick look at the project file for this, you'll see there's a couple of additional things I've added here. First is Aspire's Service Bus SDK, and then finally I've added the Service Bus SDK itself. So you've got the Aspire support for the Azure Service Bus emulator and the actual Service Bus SDK. Why you've added the Service Bus SDK as well, you'll see that in just a second. And looking at the actual Aspire code now, if you remember from the last video, we were using Postgres as the database, so we've still got Postgres being started up. You've then got this additional add service bus extension method. So I'm going to call add service bus, I'm going to give that the name messaging, and then I'm passing in a few properties here to make this container persistent, bind to a local file system, and then run things on port 6001. And once you've got Service Bus running, you've got this Azure Service Bus resource, and then from that Service Bus resource, you can then call this add service bus queue extension method. You pass in a name and a name. Oh well, a name and a name, we'll go with that. So you pass in the Service Bus name, we've got a product purchased and a product restocked queue with different queue names, product purchased.v1, product restocked.v1. So now as part of Aspire, I'm running Service Bus locally on your machine using the Service Bus emulator, and you're creating a couple of queues that you can then hook your functions up to. If you actually have a look at the code to run Azure Functions, that is all exactly the same. I'm still running my Azure Functions project. I'm still adding my environment variables. You'll notice one additional thing I'm adding here is I'm calling this with environment and adding the Service Bus connection string as an environment variable, passing in my Service Bus resource. At runtime, that's actually going to put in the full connection string for the locally running Service Bus emulator. Now, if you just go and have a quick look at the Azure Functions project now, you'll notice there's these two additional functions. There's the product restocked event handler and the product purchased event handler. So let's have a look at the product purchased event handler first. This, if you're familiar with Azure Functions and Azure Service Bus, will look pretty familiar to you. We've got a Service Bus trigger. The Service Bus trigger is on the queue products.productpurchase.v1, which, if you remember, is the same name we gave to the queue in Aspire. And then we're passing in the connection to be the Service Bus connection string. Again, if you're not familiar, this will be parsed from your application configuration, which will use environment variables, which is why we're passing in the Service Bus connection string here. So when you run this Azure function locally, it's going to connect to that locally running instance of Azure Service Bus. The business logic in here is largely irrelevant. We're parsing out the body of the message that comes in. We're going to load the product from the database. We're going to call the product purchased method on the actual product itself. And then we're going to write that back to the database. We're going to update that back in the database. So the business logic here is largely irrelevant, just so you know what's happening. That's what's going on there. So now we've got all of this running locally. How exactly can we start to test this? Because, well, just starting all of this up doesn't mean there are actually any messages inside our Service Bus queues. And there's a couple of options you have for doing this. The first is using what Aspire calls custom resource commands. Custom resource commands allow you to extend the functionality of the Aspire dashboard to allow people inside the Aspire dashboard to call custom code. So what this actually looks like inside Service Bus, I'm just going to put back in two pieces of code that I removed earlier. I've got this with Service Bus test command. This is just an extension method inside my own code base. So when you call this with Service Bus test command, the first thing that's going to happen is that the actual Service Bus client is going to be created. So we're going to create a new instance of the Service Bus client. That is why you added the Azure Service Bus SDK to this project in the dependencies. First thing, so the one thing we need to actually configure the Service Bus SDK is the actual connection string for Service Bus. Thankfully, these Azure Service Bus queue resources implement what's called the iParent resource interface, which sets the parent of the queue to be the Service Bus emulator itself. So you can call builder.resource.parent.connectionstring.getValue. That's going to pull the connection string from that Azure Service Bus emulator, and then you can use that to actually configure the Service Bus client. Now you've got this Service Bus client inside your dependency injection container. And then these custom resource commands inside Aspire are configured using this with command extension method. When I call with command, you need to give the command a name. I'm passing in, remember, this is a generic with Service Bus test command extension method. So the command that you create is going to have the name of the queue. Then the display name inside the Aspire UI is going to be send to the name of the queue. And then finally, you can pass in this function that will be called whenever someone clicks the button inside the Aspire UI. So when someone clicks the button inside the UI, you're then going to pull the Service Bus client from your dependency injection container. We're going to create a new sender on the Service Bus client, sending to the queue name that's been configured, before finally sending the message to that queue. Make sense? Let's see this in action now. So if you run the Azure project locally on your machine, that's going to start up all of the required infrastructure. Sometimes the Service Bus emulator takes a little while to get started. And everything's up and running now. So you see you've got our database, you've got your Azure Functions project, and then you've got this messaging resource, which is the Service Bus emulator. You've then got the two queues, product purchased and product restocked, which are the two queues that were created when Aspire started up. You've got the product restocked and product purchased. So if you look at your product purchased resource, open up the menu on the far right, you'll see you've now got this send to product purchased. This is going to call, when I click send to product purchased, that's then going to call this Service Bus test command. And to prove all of this to you, I'm going to set a breakpoint inside Aspire, and then I'm also going to go and set a breakpoint inside my actual product purchased event handler. So we'll put that breakpoint there as well. So when I go back to the Aspire UI now, I call send to product purchase. That's first going to drop into the actual Aspire project where I'm hitting the with command method. I'm going to parse out the Service Bus client, create the sender, and send the message. If I let this continue now, that's then also going to hit the breakpoint inside my actual product purchased event handler. This is the actual Service Bus Azure function now, and I can step through here. This should probably fail because the message, because I've not created the product before I've actually called it. So that's probably going to fail. Azure Service Bus is going to try and retry this a few times as well now. So if you imagine now you're a new developer coming to a project, you come to the project, you've got Aspire, you think great, you start Aspire up locally on your machine, you get the Aspire dashboard, and then from inside the dashboard, you've got this ability to actually be able to send test commands into the actual Azure functions. Now, although this is using an emulator locally on your machine, because this is an Azure provided emulator, I'm pretty comfortable with this as a mechanism for debugging. Now, this is of course all well and good for your developer experience inside your IDE, but what about when you're actually trying to test this as part of maybe a CI/CD pipeline? Because you all have integration tests in your CI/CD pipelines, right? So as I'm sure some of you can probably imagine, this works in a very similar way for when you're running integration tests. If you go and have a look at the actual test project now, as you saw in the last video, you've got this test setup fixture. This is going to run once when your integration tests start up. And this is where we actually use the Aspire testing support to actually create this distributed application testing builder, passing in our Aspire project. Now, whenever you run this integration test, it's going to start up Aspire as part of your integration test run. And then you can parse out things like the HTTP client from the functions resource and the HTTP endpoint. And previously, after you've created that HTTP client, you created this new instance of an API driver. The API driver just groups together all of the different methods for interacting with your API. And previously, you just passed in the HTTP client. Now you're also going to pass in a new Service Bus client, grabbing that connection string from the messaging resource. So if you remember in the Aspire project, when you created the Azure Service Bus emulator, you gave that the name messaging. So inside here, I'm going to look at my app, my distributed application, and I want to get the connection string for the resource called messaging. So you've got that name mapping there between the two. Now I've got this API driver, which has both a HTTP client to call my HTTP endpoints and a Service Bus client to send messages into Service Bus. If you have a look at the actual tests now, there's a couple of additional tests in here now. So previously we just had these two methods to create a new product, to test that product creation works, and to test that after a product is created, it can be retrieved, testing the actual API endpoints for our API running inside Azure Functions. You've also now got these additional methods for can create new product and restock, and can create new product and purchase. So this is going to test that a new product can be created, then a product restocked message can be handled by Azure Service Bus with a stock level of 10. And then when you get that same product again, the stock level should be set to the same stock level as the message. This is testing that the message that gets sent to Service Bus gets properly handled before then being retrievable by the API. This inject product restocked message, as you can probably imagine, using the Service Bus client we configured as part of the startup to create a new sender and to send a new message to the products.product.restocked.v1 queue inside Service Bus. That was a lot. Let's see that in action now. So let's go over to the tests inside Rider. I'm going to call the can create new product and restock integration test, and I'm going to run that integration test in debug mode. And then I'm actually just going to make sure I've got my breakpoint inside my actual handler, which is just there. So there we go. We've hit the breakpoint inside our product restocked event handler. I'm going to step through here just to make sure all this works. So the product should actually exist. Yep, we've got the product from the database. I'm going to call restock and I'm going to update that and then let my test continue. And if I very quickly just go back over to my tests and drop a breakpoint in there. So because this is running asynchronously, there's this task.delay to give Azure Service Bus time to actually work. In the real world, you should probably run that on a loop just to do retries so that you're not just en masse waiting 30 seconds. So what you've seen there is two options for running Aspire locally on your machine and reacting to events that are published to Azure Service Bus. And for the other event sources that are available in the Aspire integration, there are emulators for Azure Event Hubs, there are emulators for storage, and there's emulators for Cosmos DB. Now, some of these are better than others, to put it lightly, so use them with caution. And remember, as I said in the last video, this isn't always foolproof. You should always test in the cloud as well as testing locally as well. Emulating Azure Functions locally, emulating Azure Service Bus locally certainly allows you to step through and find issues more quickly without needing to deploy to the cloud, run the test, make a change, deploy to the cloud. But it doesn't solve for permissions issues, for misconfigured identities, for misconfigured event sources. So testing locally should always be a first step. And getting that fast feedback loop inside your CI/CD pipelines to be able to to be able to push some code, run some integration tests, and have a decent idea that at least your business logic works is really, really powerful when it comes to fast feedback loops. But remember, always test in the cloud after that. And that's it. Aspire, Azure Functions, perfect for improving your local developer experience and allowing you to ship better software faster. I'll see you all in the next video.